Hi everybody. So tonight we're here to give the Dart talk, and just so happens we happen to have like an interactive Dart game for the wrap up. So that'll be like interesting because we also have some swag to go with like however interactive the interactive game becomes. And oh yeah, swag. Look at this.
You get yours to drink here.
Beer swag and the darts. What can we do better? What else is going on? Okay, I guess I should talk about some community announcements and just see if anybody's hiring or anybody's got any other interesting announcements going on. So maybe if we kind of start over here. And that could be like if you have a startup or if you've got a position in your company. And usually people looking for positions or just like need a position, period. So there's like any interesting little tidbits you'd like to share. Thanks.
We're hiring at Aperture. We're especially interested in people who like working on the front end. We use Clojure library, so hopefully a lot of people here are interested in that technology. So if you're interested in learning more, come talk to me later.
Thank you. Thanks. And any more? Thanks.
I work at Tableau. We're hiring front-end developers. We kind of work in Script-Sharp and then a mixture of other compiler technologies, which is a little off, but and we do visualization and analytics, which is really powerful.
Awesome. Thanks. Yeah.
We're hiring at Zynga. I'm probably not the right person to talk to, but I can tell you who is. Basically front-end dev, if you like Flash, and then back-end development in Node.js.
I also like helping out, been helping out from the Duke meeting at AWS, and it's like you have to start out the meeting with like who is not hiring the Duke engineers? It's like everybody's hiring the Duke. So anybody else? Thanks, Jerry.
Hey, I work at Twilio, and Twilio is hiring, so feel free to find me after the meetup if you want to talk about it.
So, by the way, does like anybody else have like any meetups they want to announce, particularly related? Any more? Yeah, one more.
I'm Michael Patrick, and I organize the Tech Speeders Workshop meetup. Meets down at StartPad, and it's kind of an open format. Yeah, if you're giving a presentation at work or at a conference or whatever, you can give it there, get some critique on it. We're always looking for new people to participate. Thank you.
Thanks. That's because Mike, who really is the organizer of the meetup, is also runs StartPad, and happen to know that in down there, myself doing some coding and so forth. Seems like it's getting some like open cubes down there, and it's a great deal. You can get like 3 people in a startup into a room, and it's like $900 a month. It includes everything like Wi-Fi, copy, you name it. So it's like it's a good deal compared with other incubator type arrangements. Okay, so I want to just give some thanks tonight to Brandon for like creating this game. If you saw his interactive game at Warm Beach Camp, it was like these snowballs on the the world's biggest GUI game, and so tonight it's creating the world's biggest darts game, I believe. Check that out later on. Anyway, so Seth, give us some applause.
All right, thank you. Before I get started, I want to thank Clive and Brandon for setting this up, and especially for the cool balloons. They did a lot of work on that, so I think it's going to be a lot of fun. I'm not sure how exactly it's going to happen, or how exactly it's going to work, but we do have a couple of Dart pint glasses here that somehow you will win by playing this game. Played by here. And thanks to Chris for setting it up and running it. Appreciate that. Google's kind of cool. We do a lot of different things there, and I took as part of the developer relations, we get trained on speaking and presenting, and so I took this really cool class, and I'm going to apply it here tonight. And so to explain Dart, I'm going to do it through interpreted dance. This is very for real. So it was a really cool class. This kind of guy was out there a little bit, but he taught us some cool stuff. So here we go. I'm just kidding, dude.
No way.
Oh, good, right? You feel dark? That's right. No, each one is unique. As I said, my name is Seth. I work in developer relations. I'm with the Chrome team. And Chrome is really cool because you have a wide variety of products. Yes, Chrome. Including, obviously, Chrome, the browser, which we all know and love. Chrome Web Store, where you find your apps. Chrome Frame for your legacy browsers. Chrome OS and Chromebooks. HTML5 for all the APIs for program docs maps. And most recently, what I'd love to talk about tonight, and what's very near and dear to my heart, is Dart. So our goal, very succinctly, is we want to help app developers write complex, high-fidelity, high-performant client apps for the modern web. So that all sounds really cool. And you can probably notice there's a key word missing here from this sentence, right? The word Dart is actually nowhere on here. And I think that says a lot from its omission. That is, if you're able to write these high-performance, high-fidelity, complex, multi-featured HTML5 modern web apps in any language environment, API, compiler, toolkit, that's fantastic. At the end of the day, that's what we want to see. We want to increase the number of apps on the scale of Gmail and Google Docs out on the web. Google was born on the web, makes its money from the web. It's the most ubiquitous platform out there. We need to work very hard to continue to ensure that these compelling apps that users, customers, clients are demanding can be developed for and deployed on the web. So again, if you're doing this in whatever toolkit that works for you already, that's fantastic. But there's a whole army, a legion of developers out there from different platforms that have high expectations from their languages, their libraries, their compilers, their tool chains, their editors. And we think that there's room here to innovate a new compelling option for all these developers to bring the apps that they envision in their heads to the web platform. And we think that Dart can be that compelling platform option. So what is Dart? Structured web programming. I actually think this is more like structured web apps. That puts it a little bit more squarely in the problem domain we're trying to make easier for you guys. It's a full batteries included effort, full end-to-end platform, new language, new virtual machine, new set of libraries, new approach to the DOM, new HTML libraries. Coming soon, things like UI framers. There's a whole editor. There's an SDK. The whole project is open source. Came out in October last year. We launched as technology preview. What we mean by that is, oh man, sorry, can't see that at all. Yeah. So technology preview to us was we wanted to launch early enough to get the feedback from the community and the app developers from all these different platforms to make sure that we're building the right thing or things. But we wanted to launch with enough code there that showed the effort and the direction and the motivation that we wanted to move in. So, we didn't launch with an empty repository and say, hey, we think we want to reevaluate, reapproach web programming. Well, we didn't finish it and then launch either. So we're still in this technology preview mode. There's a lot of work to do, and but we're headed for beta pretty soon. So tonight, we are going to look at motivation. I think we're going to spend a lot of time on that. A talk full of code is pretty boring. We're going to look at the language. We're going to look at features like isolates and the new DOM libraries we've been building. Certainly some code samples and some demos. And then we'll take cool questions and pop some balloons. So the current web, right? What's the good parts? Obviously, it's doing a lot of things well. Again, it's the most ubiquitous platform out there. Small to medium-sized apps, certainly easy to build. We can see that everywhere. Small to medium-sized apps, very easy to start. It's very easy to iterate in the web programming model. That's definitely a strength, both from being able to just add a couple of functions and redeploy to not having to re-download, say, 2 gig app for every client every time you push a 1K patch. These are all good strengths. No application install. You just click a link. That's a fantastic model. The platform itself is improving very fast. I mean, you can look at HTML5 as evidence of that. And fantastic new APIs like an app cache for offline caching, a file system API, a web audio API, new input controls. I mean, the list definitely goes on and on and on. And I can barely, our whole DevRel team can barely keep up with how fast the platform is improving. But that's kind of near and dear to my heart. So I worked on help bringing Angry Birds to the web. And that to me is it's a modern web app. It has or requires a very fast JavaScript engine. It requires hardware acceleration for its graphics, like Canvas or WebGL. And we built it to work offline. So to me, this is kind of it's a symbol of the modern web app. Either you can play or you can't. And last time I checked, using just public stat counter, greater than 50% of all the desktop browsers out there, which is some number, hundreds and hundreds of millions, Chrome alone is 250 million active users, can play Angry Birds. This is across Safaris and the Firefoxes and Internet Explorer 9 and the Chromes. That's a really, really big number. And if you look at the numbers from the other platforms like Android or iOS, this number dwarfs that. So it's good. I mean, the platform is very, very big. We think there's also some challenges here with the modern web platform. We think developing large applications is still too difficult. It's hard. Where large is on the size of Gmail, right, or Google Docs. Evidence is there's just not that many systems out there. It's hard to find the program structure, right? Where is the main method? Where does it start? Where are your modules? Where are your classes? Where are your libraries? How do those all fit together? The lack of static types, frankly, is kind of a bug, I think. And the fact that when you scale to tens to 100 developers, how do you convey your intention for all these methods to people that you may not work with in totally different time zones? All these other languages and all these other platforms have this concept of static types, which we treat like annotations, to help convey more meaning. And we think convey more meaning, and it's easier to collaborate across larger teams. The web developer today hasn't embraced structured tools either. There's kind of a lack. It's a weak tool support. This is getting a little bit better. IDEs like WebStorm are doing a pretty good job. In fact, they can actually read the CSS in a string that you have in the JavaScript file. Like, that's pretty cool. But the fact that it's taken us 15 years or something to get to that point, refactoring support is still incomplete due to things like eval. We think the tool support could get better. Yes, question?
I could swear I've seen the similar slide like this for GWT. How does Dart relate to that? Is
cool,
it
you skipped right to it. Yeah, I always get that question at the end. So the question is, that's fine.
I mean, those are the same points.
Absolutely. So the question was, I could have sworn this was the argument for GWT. What's up with that, right? Okay. Excellent. So WIT was almost a technology ahead of its time in a sense. This bit, for those of you who don't know, you can write Java code and compile it down to JavaScript. And it did a lot of things right. It had very smart compilation. It could split your code to be optimized for different browsers. It could take images and create data URIs, resource bundles for you. It obviously worked with static language, so you could do a lot of refactoring, all this great stuff. But what we found is that the web developer community at large, the army of guys writing web apps today, didn't embrace WIT as a tool. There's probably a couple of reasons for that. One, it wasn't a language that felt very familiar probably to the normal web developer out there, I guess the stock web developer. The iteration process wasn't as fast as it could have been. What's fantastic about the web, I think the slide previous was, iterations are very fast, right? We make a change, reload, make a change, reload, deploy, right? That's a fantastic workflow. You know, and there's probably some other reasons. So WIT has powered some really fantastic apps like AdSense, the AdSense UI, the Google Flight Search, and a tremendous amount of enterprise apps that we don't see, but it really took up there, obviously, because there's an army of Java inside the firewall. But it didn't push the web forward as much as we wanted it to. So WIT is definitely still around. It's used for a ton of different Google projects internally, but the releases are slowing down, and the use cases are driven mostly by kind of our internal needs. It's still an open source project, and there's a lot of developers. I remember Google I/O, some of our highest rated sessions were on WIT. But again, it didn't push the web platform forward by giving the tools that web developers need to build these kind of complex, large, high-performance web apps, even though they probably could have with Quit, and I can think of a couple of examples that happened, like Angry Birds was written with Quit. So certainly Dart is trying to approach the same problem, right? How do we help developers from all different platforms bring the apps they envision in their head to the modern web? We think that Dart, as this fresh approach, is being built essentially from day one to appeal to a much broader range of developers, from the stock web developer who has never seen a type, probably doesn't want to see a type, all the way up to the programmer who wants to write the abstract class factory. You know? That is, there's a whole gamut of developers who have different expectations for tools. Dart is being developed from day one to address those concerns. So hopefully that answers your question. And not ask again. Okay. Cool. The last bit of concern we have that we think we can do better at is slow startup time. And you'll see a feature we'll talk about a little bit there. But JavaScript engines are definitely getting faster all the time to run complex physics calculations, like in English. But the startup is still slow because you have to parse all this JavaScript, right? So we think we can do better there. So it's just kind of summed up that there's a lot of cruft that's built up in the web platform that we are hitting as we're trying to build this new generation of web apps over the next 15 years, from the previous 15 years. So what would it look like? What would it feel like? How can we do it differently if we reapproached all these problems? And so, as we talked about kind of in the early intro here, this is where we think there's a lot of room for innovation and evolution, which we think is absolutely critical. The open web platform is fantastic because it is open. New technologies are given a fair shot at trying to get grassroots support, evolving from the ground up, and seeing if they have a place in the open web. I mean, what's so fantastic is no one has control over innovation on the web, and that's a good thing. And as I said all the way back in previously, if you're building these complex, totally awesome, multi-person, multi-feature, highly performing web apps in JavaScript or whatever it is your language is, that's great. We're not here to replace JavaScript. We're actually more threatened by the proliferation of native mobile platforms, right? The user expectations are on native mobile. The developer mindshare is on native mobile. Like, it's sexy to build native mobile apps now. And that actually threatens the best thing we've done in a long time, which is the web. And so we think that if we can bring a new, compelling option to build web apps, or apps for the web, then we're going to swing the pendulum, and that's good. Okay, so enough about that. Let's dive in a little bit of details. What is Dart? So as the slide says, it's a simple, unsurprising, object-oriented language, class-based, single inheritance with interfaces. So you guys can totally yawn right there and walk out the door. I wouldn't blame you. It's kind of boring. But that's a feature. So we wanted to ensure that Dart, the language, was familiar to a vast number of developers out there from many different platforms. We could have built the next Haskell, for instance, and we would be totally awesome with our 10 users. But unfortunately, we need to appeal to million-plus developers out there that are building apps. So we needed to build something that you could become productive in and feel familiar with instantly. We kind of got dinged about it, initially. What's with the language that I think I already know? And we're like, good, okay, we got that. Optional static typing. So this balances out the familiarity. So yes, a lot of the stuff you will look at, you're like, okay, seen that, got that. But then, because we have that chance to do a fresh approach, optional static typing is probably, to me, the most unique new feature we're trying to deliver to a language that's targeted such mass adoption. We'll talk about that. Real lexical scope. If you're a JavaScript developer, this should be very good news. And I think ES6, the next version of JavaScript, also has an option here for that. And if you come from other platforms, you'll feel right at home with that. Single-threaded. This makes sense when you think that we always compile to JavaScript, which is a core tenet of the language, and JavaScript runs in a single UI thread, so we need to emulate that. But we did introduce this concept called isolates, which we'll talk about, that gives you that concurrency programming model. Okay, let's look at optional static typing. So you might be familiar with other languages that have static types that essentially force you to create some code that the type checker is perfectly happy with, and before you can ever hit the run button. And sometimes we feel that that's a little generates too much friction for the developer. So we decided to use types or apply types more like annotations or documentation. So to us, the types, they're literally optional, but if they're there, then you can convey a lot more of your intent to your fellow developers, your fellow humans, and your fellow machines with a language construct instead of things like comments, for instance, or just not there at all and walking across the cube and telling people what they are. So the type annotations, they don't have any effect on the running code. But if you do have them in there, you can run in what's called check mode. The check mode then will turn on all these type assertions. We actually think that developers are running check mode essentially all the time. And with all the type assertions in there, you'll get all the early warnings when you try to, say, use it in like a string or vice versa. This is a good thing. You're going to catch errors early. That's always good. Okay, so we looked at all that. So let's look at an example here. So I kind of alluded to this earlier. Let's say you're writing some code with your buddy, and he has, he's written some awesome method called add, and you need to add stuff. And so you look through the library, like, oh, dude, he wrote me an add. It's pretty good. So I'm going to use this add. And so you write here in your program, you're like, you know what? I'm going to print add 1, 2. Yeah, it's so much better than plus signs. Here, 3. Sure enough, it does exactly. It adds 2 things together. That's fantastic. Then you're talking about it like, hey man, your add method was awesome, it totally worked. And he's like, oh, yeah, there's a bug in that. I really meant hello, A plus B. And then, of course, if you run this, so what's happening? Oh, sorry. Right, hello, comma, 1, 2. It's like, yeah, I fixed it. It really was supposed to just add some strings together. Oh, strings. Right. Dude, well, why didn't you just put add 2 strings? Now, we can definitely fault him for not putting a good method name. We can definitely fault him for not adding comments in there. We can definitely fault him for not sending email like what this method does. We can definitely do all that stuff. But the burden is too high there. So what if you could express to your fellow programmers and to your machine what it is you're trying to do? Right? Okay. So if you add these type annotations in here, whoops, you run the program. Now we start to get warnings. So now the system can start saying things, helping you out early. Int is not assignable string. Now, why didn't it crash you? Because these are optional static types that don't affect the runtime of the program. So they're going to warn you, but they're going to let the program run anyway. But this is where check mode comes in. Because the reason is, this code here still works. Like plus can still merge strings together, numbers, and all that. So turn on check mode, though. And now you start getting the errors. Now your productivity starts increasing because the system can tell you right away, hey, you're trying to take numbers and put them where your other developer said it's a string. You probably want to fix this bug. So to me, that's kind of the evolution of optional static types, right? We think that adding the types and things to like the surface area of your program, like method signatures and interfaces, for instance, is just such a nice way to convey your intention. The tools start to pick it up, help you along the way. The programmers appreciate it. And I mean, if you come from other languages, that all makes sense. Okay.
Question?
Yes?
When you did a static analysis to determine that the strings were ints?
Say again, sorry?
Are you doing that at runtime, or are you doing that with some sort of like static analysis tool you built?
So the check mode is at runtime.
But non-check mode, it emitted warnings?
It's during the compilation phase of the program.
All right. So if there was like a set timeout 10 seconds there before you ran your print function, I wouldn't have to wait 10 seconds for the warnings to appear.
That's right. Yeah.
Right.
Yeah, if you do it inside an if 0, you'll still get the type check.
Okay.
Yeah. No. It's compilation.
Oh, sorry.
Compilation program. Static analysis runs based on what it can infer, but it runs the programs as if the types weren't there.
Okay.
Now, of course, obviously, A and B still have the objects behind the variable references. A and B still have the types AR numbers or AR strings and all that. So, yeah. So if you try to write, obviously, it's not going to let you run any arbitrary code. If you try to do, like, a program that doesn't work, it will fail still. But, yeah, okay. Good question. Cool. Another new cool feature with Dart are isolates. I mentioned earlier that Dart itself is single-threaded. So that makes sense, but that doesn't mean we don't get to take advantage of our new 64-core machines. So we have a concept of isolates. Inspired by DartLang, you you can think of isolates as very lightweight new processes that you can spawn and pass messages back and forth. This allows you to, say, spawn a new set of running code, memory isolate it, that possibly might resolve to another thread or process on your machine, and now you can communicate by passing these messages like maps or strings back and forth, and when the other isolate picks up the message, he'll operate on it, he can send replies back and forth. So these isolates are really kind of cool because there's two different ways to run isolates. There's the concept of lightweight isolate and heavyweight. You can think of like how it resolves to JavaScript. A lightweight isolate would run in the main UI thread, and will just block that thread until that isolate's done, you can carry on. But a heavyweight isolate would resolve itself to a web worker, for instance. If you're not familiar, web workers let you run code in a separate process in your web page. And you communicate by sending messages back and forth to the main page, the web worker. It allows you to run lengthy calculations without blocking the UI thread. Same kind of concept with isolates. The other kind of cool thing about isolates is you can think of any modern web page today. We have analytics snippet in there, and a plus button snippet in there, and a Facebook like snippet in there. We have all of these crazy JavaScript snippets that we cut and paste and place into the page. They're all kind of running in the same memory model, right? And you kind of have to trust these guys that they're doing the right JavaScript practices and patterns to not kind of step on other people's variables and whatnot. What if you could run each one of those little components in your web page in a separate isolate? Thus having memory isolation and protected from the rest of the parts of your program. So, thirdly, we envision isolates to be able to kind of mask or smooth over communication, not between just components in your app or components in your page, but components between a client and server. So today, a modern web developer would use XHR and open up some URL and post JSON back and forth. But if you can kind of rest an isolate on top of that, then the programming model now feels familiar from intra-app, from intra-page, and then intra, I guess, pieces or client-server. So a lot of different cool uses for isolates. Yet another totally awesome feature being able to reevaluate the web programming model is taking a fresh look at the DOM. Those that don't know, the DOM is the document object model. It's how you access the browser, the different elements in the page, attributes, classes, etc. DOM is really cool, very cool feature, except that it was built in very language agnostic. It never feels native to program in the DOM in any language you're in. So every language usually creates their own DOM. For instance, jQuery is extremely popular because they did a fantastic job making the DOM feel like JavaScript. So of course, if we're going to make a new web programming platform, how do we make programming the browser feel like Dart? So we built a nice new higher level library, and we'll see examples of this soon, called the HTML library that makes accessing elements feel like Dart collection. Setting CSS classes as simple as setting or adding or removing strings from any other set or list. It should make programming the browser feel like Dart, just like jQuery makes programming the DOM feel like JavaScript. Okay, so we've talked a lot about the different features and what the language looks like, but how do you actually kind of execute this? How does the rubber start hitting the road? There's a couple different ways. So we're always going to start with some Dart source up here, and then you can kind of branch in two different directions. One, you can run the code straight on the Dart virtual machine. This is kind of cool because Dart's design is not painting itself into any kind of corner that it can only run in a browser on a client. So on the low-level VM, the low-level language, and the libraries can also run on the server. So you can run a Dart VM, say run something like node.dart, and communicate to your Dart app in your browser, which might also have the Dart virtual machine integrated directly in it. More likely, though, you're probably running Dart code that's gone through a set of tools that's compiled your Dart to JavaScript. JavaScript's the lingua franca of the web. Everyone has JavaScript. It's crazy important that any language you introduce to the web can compile to JavaScript. So we're compiling JavaScript as well for our tools for modern web browsers, like the Safaris and the Firefox, whatever they're on now, 7 Plus, etc. And then there's this other really cool feature here, snapshots. So snapshots kind of addresses one of our other concerns you can remember all the way back to like what's a concern with modern web development today, which is application startup. So a snapshot allows us to take a serialized heap of a running Dart program and instantiate it from the serialized heap, not from reparsing all the code. So an example here is we took about 54,000 lines of Dart, And if you just start that up from the source, it's 640 milliseconds. If you start the same app from a snapshot, an order of magnitude better, 60 milliseconds. We think this is pretty impressive. We like this. You can think of a model where you might visit a large Dart app. It downloads all the source code. It compiles the whole program. Right before it starts running it takes a snapshot, stores that in your cache. And then if you reload the app, it will load it up from the snapshot, not from the code. Like, that's a huge improvement over startup, and that's anything we do to make apps feel better, start up better, is good. But this, I guess, it's obvious, but it requires a virtual machine to read in the snapshot. By the way, do you have any questions and stuff?
Can you snapshot normal JavaScript code, or do you have to?
No, this is a feature of the Dart virtual machine. Yeah.
So you haven't figured out like a way where you can.
Well, I mean, could we add it to V8? Is kind of what you're saying.
Yeah.
Yeah. We'd have to talk to V8 guys if there's anything specific about the language design. I think there might be a specific language design in Dart because, for instance, Dart programs, you compile them all the way through, and no code is actually executed through that pass. I think in JavaScript you can write code that you can
write
actually
code
execute through the
code.
pass. So I don't know if this snapshot makes sense in that model, but you definitely have to talk to VM guys. I don't know.
V8's doing some snapshotting work, but it basically, as soon as you touch anything that's not side effect free, as soon as you touch the DOM or the outside world, it has to stop the snapshot there, right? And top-level JavaScript code can do anything imperative that it wants to do, whereas Dart's grammar is it's more like a static language where the top level of the grammar is all static definition, so you can get all the way down and start snapshotting.
I don't know. So if you heard the question, the answer to the question was, could we do this for JavaScript because it's pretty cool? And the answer, it sounds like, is V8's already doing something close to this, but because JavaScript lets you do whatever, whenever, it will stop the snapshotting process as soon as you, say, touch the DOM or just execute the code that starts to run. It's not just part of the compilation. So I guess maybe it sounds like maybe you could write a specific subset of JavaScript that might do something like this, but again, that's only, sounds like it's only specific to V8 anyway, but yeah, good question. Okay, so let's look at a sample. So that's a lot of the high-level theoretic and features and stuff, but does it actually work? The answer is yes, most of the time, depending on what happens in the next second. So the neat thing is, the Seattle Dart team here was tasked with, and is tasked with looking at what the UI libraries might look like, what the app stack might look like. And to do that, while the teams were building the virtual machine, the libraries, and the language, they said, okay, we're going to build a real-life app. So they built this really nice app called Swarm. It's a views reader. It's running an app engine. This is actually the JavaScript version. And the neat thing is that they've been pioneering what do the models look like, what do views look like, what does observable views look like. But they did a lot of great work here to show that you can actually build modern apps with Dart. And this is actually all open source. You can find the repository today. This also runs on an iPad. I apologize, I didn't bring my iPad. But they also developed all the touch libraries. This is, and correct me if I'm wrong, there's a Flexbox model implemented in Dart. If you don't know Flexbox, it's kind of like actual layout for CSS. It's what we've been wanting for like 10 years. Written in Dart that actually compiles down to JavaScript if you don't actually support Flexbox. So it's kind of cool there. And yeah, it all works on the iPad too. So yeah, this is a fairly large, I mean not tiny, application, 3,000 lines app code, 13,000 lines UI code, about 500K of JavaScript. And that's kind of cool. Open source, you want to see what we're thinking there. Moving on, full stack means editor included. So we bought a company, Instantiations, that did a lot of tooling around GWT. And we said, okay, forget everything you know about GWT and build us something awesome for Dart. So they took the RCP, which are just low-level component libraries, and built an editor just for Dart. They took out everything. Only what you need for Dart is back in this editor. And I'll show it to you now. This is definitely a work in progress, but we have run some hackathons inside Google, for instance, and people love this tool for getting started with Dart because it gives you the instant feedback with the syntax highlighting and the code completion, which we'll see in a minute, and browsing the library. So if you need some place to start, I recommend the editor itself. And we'll come back to this in a moment as we see the tools. This is like everything else open source. We also have a Dart SDK that's kind of stealth launched, and we'll do some docs around that pretty soon. But these are pre-built binaries of Dart virtual machines. You can play with Dart on the server side. You can also plug the Dart VM into the editor. We have the compiler to JavaScript, which is affectionately called Frog. It's Star Frog, so I guess it's poisonous. So I think that's a great name, but that's cool. And the Dart libraries as well. And this is just a nice little zip, so you don't have to get all the source and get all the crazy Google tools just to play with Dart. And we'll document this more soon, but it's definitely out there. So we're still in technology preview. So Dart itself is definitely not done. There's some low-level stuff we still have to work on. Things like reflection support, which is definitely coming. I think that's one of the next features to land. We just published changes to equality. For instance, in JavaScript, you have double equals and triple equals. Double equals will do a type conversion. Triple equals will check value and type. And people always mess that up. And Crawford will tell you just always use triple equals. So we kind of reevaluated how we do equality, and we definitely smoothed out the semantics there, I think. For instance, just use double equals, and there you go. You don't have to worry about the rest. It will check if either side is null. It will check if it's literally the same instance of the object, and then otherwise it will delegate to a .equals method or a .eq, where you can just define it. So anyway, we're trying to smooth out a lot of these bumps here. But then there's other features we need to do too, like should we have enums? Pretty popular feature. Pattern matching, if you're going to have actor-based concurrency. How do we ship Dart from Chrome? So it's still early, and so we encourage you to check out the open source program and let us know what it is that you need. What does modern web app architectures and frameworks look like to you? We have virtual machine, libraries, compilers, everything, editor, all open source, mailing lists, issue trackers. Okay, cool. The community itself is growing. We have a number of active Google Plus pages run by the community. Dartbit, #DartLang seems to be the emergent hashtag out there. Dartosphere is your planet. They're aggregating all the RSS and atom features. This is great. Try it at dartlang.org. You can actually write Dart in your browser. You saw it earlier. You don't have to download anything, and you can try playing with it today. And please do send us feedback. And I've given this talk a couple times, so Dart's constantly evolving really quickly. So if you think you've known everything about Dart, a couple things happened the past couple of days. We're about to push out cross-site search, which is pretty cool. We'll search the API docs, reference docs, the blog. We just pushed out a new news and updates feature. It allows us to push more stuff to you more quickly. And then today we just pushed out synonym.dartlang.org, which maybe you guys saw it on Ars Technica. A lot of those guys have really insightful comments. But this is an interesting mapping between syntax of JavaScript and Dart. So admittedly, this doesn't you don't really see the forest from the trees here, but this was built by a JavaScript developer who is very familiar with JavaScript and wanted to map kind of his patterns and idioms to Dart at the syntax level. So we built this very long page, and I hope to get more feedback to add more features between everything on how do I compare things, what are strings, what are lists, what are arrays, how do I create a class, how do I do things in jQuery. So hopefully we've covered many of the cases in here. So if you are very familiar with JavaScript, I ask you check this out and see just how syntactically you might map these things back and forth. Where are we? Here we go. Cool. So to sum up, before we kind of dive in, do some cool code samples here. Remember, Dart is a very batteries-included platform. From everything from the virtual machine all the way up to, coming soon, the UI between the editors and the language itself. The sweet spot, I think, is structured web app development, structured web app programming. We want to make it easier, more compelling, more attractive to build these complex apps. We think that Dart's full platform helps to do that. And we're still in technology preview mode. We're not even in alpha state, so it's still early to give us feedback. Star bugs are important to you. Try it out. Let us know what you need for your next web development stack. DartLang.org has all the links that you need. So with that, let's dive in a couple code samples, just to give you a sense of a lot of talk in this show. So actually, let's do this in the editor. Okay. So we saw this really briefly. Obligatory hello world. What I like about this sample here is it highlights the language is not Java and it's not JavaScript. It's Dart, and we're evolving what that means. But you don't have to take everything you tried to do in Java and map it to Dart, or everything you tried to do in JavaScript, or all these other languages. It's going to evolve its own voice, and we're able to add some new features here, like the shorter one-line method signature, or function signature, or implementation. Here's a little bit more meaty example, so you can see that. Okay, so here's your class point. A couple interesting things here. This constructor here, we'll just take the types out. I like this. Everyone does this.x, this.y equals x equals y in every constructor I've seen. So we said, hey, well, let's just say if you have this.x in the constructor signature, we'll just put this.x equals x for you. It's kind of a nice advantage. So you can see we didn't put a type and a return type here for distance to optional types. If you're familiar with the simple var syntax, that works for declaring variables. And down here is string interpolation. So we're trying to make it a little bit easier to work with text. Okay, so that's kind of cool. We talked a lot about optional types. What do they actually buy you? So when you have the tools of things that come from other languages, and this is probably a no-brainer, but let's say if I have P right now, I can't do any code completion here because my system doesn't have, we haven't built the type inputs yet, we haven't said what P is. But if I add my type, immediately it says, oh, I know it's a point, let me help you out. And this is just fantastic. If I can do this in a predictable, fast way, I think we're going to speed up development.
So you said that you are going to build type inference as well, or?
I think the idea is that under some circumstances, we can have type inference.
Yeah, like that situation there.
Yeah, right, like, kind of obvious at the point. Yeah. We're not quite there yet, but okay. You can add a type now, and okay.
Although if you have
C#
type inference, then it's no longer optional. Then you have to have a special syntax to say, oh, I don't actually want type inference.
I think you just get it for free. Like, type inference would be, and again, we're speculating what it will be, so it's not that bad. Our P, like the editor will know that P is a point because you're initializing it to a new P right over here. The running code, the running program semantics still runs as if your optional static types, but that's on the left-hand side, right? It's still a P object instance, regardless of what I put, right? So sorry, let me go back. So I have my point. Okay, you saw that. I want distance to, knows it takes a point. Okay, put a key there. So again, adding the types helps your fellow humans, but then also helps your tools, and you get kind of neat things like code completion. Let's look at one of my favorite things is the new HTML library. This is our fresh approach to the DOM. So I don't know how familiar you are with JavaScript or jQuery. Hopefully this makes sense. We have import Dart::HTML. That's how you include a new library. So we can have this concept of library for your modularity. And here we can create a new tab for, and we go just a brand new button. And adding an ID and text, that makes sense. So now we get to start getting kind of cool. So element.classes, this is actually a set of strings that represents the class string names. But because it's a set, that is, it's just a first class collection, and I can call collection methods like add. So I can add importance. So I don't know, this reads pretty good, pretty well to me. But then we get to really cool. This is your event handling. So instead of .add event listener click function, we can say element.on.click.add. We have here our inline function here, when we have a window alert clicked. And then we take the button that we have a class, we have an ID, we have some text, we add it to document.body.elements.add, because elements itself is a Dart collection. You can add things to it, you can remove things from it. It kind of feels like native Dart code. So what does that look like when we run it? Well, I'm going to pull up here Dartium. Dartium is a special build of Chrome that has the Dart virtual machine embedded right in it. This is actually open source too, and soon we'll release binaries. You can play with just Dart without compiling to JavaScript, which I found is a really nice development workflow. And then when you're ready to push, then you compile the JavaScript and push all that out. But let's take a look at this. So we're going to run the code. Whoops, ahead of myself. Oh wait, here we go. Run the code. Okay. So click, awesome app that I just built. So that all works with the click handling and the alert. But now we start to get things like debugging, which you saw briefly here. I can now use it in developer in Dartium, set breakpoints, just like you can with a normal JavaScript program. And if we then reload the program here, you can see that developer tool says, okay, I'm going to stop here in the breakpoint. My program's in the midst of running. I haven't added that button, obviously. So then if I skip through the breakpoint, now my program is finished and I can run. So this is the beginning of the debug story. So we've seen editors with code completion and library browsing. You can load it up into Dartium and actually start running with the dev tools and start setting breakpoints. I don't think the variable introspection stuff works yet, but we got people working on it. So this is really, really raw stuff. You can see the direction we're working on. And then with something like source mapping, which allows you to take a compiled language, like you might compile CoffeeScript to JavaScript, but you might want to debug the JavaScript, so you want to map your compiled JavaScript to CoffeeScript. There is this concept of source mapping. Wit can do it, CoffeeScript can do it, I think, and someday Dart can do it. So the debug story is coming. And there's probably one other kind of cool. Well, let me show one kind of cool thing here. So, yeah, this is way more interesting. Okay, so we talked about isolates. Isolates again allow you to run code in memory isolation and protected and allow to pass messages back and forth. We talked about the different use cases for isolates, things like just riding on different cores on the machine. Passing messages between those web workers, smoothing over communication to a client and server. So here's just an example of what isolate code would look like. Here we have, this is just all going to run in the virtual machine. This is a very simple example. We have an echo server here, which extends an isolate. And we're going to say, okay, we're going to listen for messages, and when I receive a message, just send a reply here that will echo the message, and then close my port. So this is a one-time echo server. Here's the sender. You can think of this like the client. Start here. We're going to send. So we want to first create a new echo server. We're going to spawn the isolate. Then, that is, when the isolate's ready to talk to, he's going to give me a port here, and I'm going to send it a message of hello. Okay, which is this call right here. Then I'm also going to construct a reply port. Basically, I'm going to tell you hello, but I'm also going to tell you how to respond back to me. That's what this code is. This is the receive port. And if we run this code and click right here, this is all in the editor. So that just ran it on the virtual machine, which I got through the SDK. Here's my send hello, here's my response echo hello. So this is really simple echo isolate-based service.
Question. How does isolates compare to, say, being coded in an iframe in order to isolate?
Yeah.
What sort of latency is isolates?
Sure, so compare isolates to iframes, for instance. So iframes will still run in the main UI thread. So yes, they will communicate to your main host page via post message. So similar to this, send a message over a port and listen to another port some other time. But isolates, if you create heavyweight isolates, will run in different web workers, and thus on different threads or processes. They would be, I could imagine a browser architecture might run iframes in some sort of concept of isolates as well, but I don't understand enough from implementation details to understand that quite that. This basically allows you to, in your program, make a decision on how heavy or light weight you want the isolation to be, based on what you want to get done and how fast and how complex your calculation is. But they're also very useful on the server as well, where you might have something like node.dart, you might spawn isolates to handle different concurrent connections.
So what sort of latency?
That's a good question. I haven't measured. It's fast, so I don't have the actual numbers. I mean, this is the time it takes to start up the VM, compile it, start up one isolate, start up 2 or 3 ports, send a message back and forth, and stop. I mean, it's fast. I don't know if we have any numbers on isolate performance, but I suspect we'll have to publish that stuff recently. Yeah, good question. And I think I wanted to see if there's one other that left. Yeah, that one. Let's see if this one really good changes. Okay, yeah, we'll end on this. And I hear a lot of whispering, so hopefully we'll get questions. There's another example, just we can smooth things over when you reapproach. And to be very fair, ES6 also smooths this over quite well. So if you're a JavaScript programmer, you might write a loop something like this, where you might have a bunch of different callbacks. And you say, okay, well, I have a for I equals 0 type loop where I'm going to iterate through my values of i's and assign them or give them to each one of my callbacks. And then later on, I want those callbacks to activate or be called or whatnot. So if you did this in JavaScript, more or less as this is written, you would actually get 2 and 2, which is kind of odd. But we're not, in the current version of JavaScript today, we're not, and I apologize, I'm not going to get the exact right word, we're not closing over the variable in the way that most developers would expect. Most developers think, like, okay, if I run this, I want to get 0 and 1. So we run this in Dart, sure enough, it gets 0 and 1. So we've kind of fixed the behavior of the for loop in Dart. Just another example of being able to kind of reapproach this stuff. ES6 will allow you to get around this with let, yeah. But you still have to say let j equals I. There is a way to get around this in JavaScript today where you have to wrap the whole thing in a IIFE immediately execute function.
Oh yeah,
I'm screwing up the acronym, but yes. So anyway, that's another example. Okay, finally, I want to end with this. So you might have seen when we first announced project, somebody took our compiler and compiled Hello World and got something like 700 megs of JavaScript. Which, yeah, so Dart is not done, technology preview, etc. And we obviously that's not acceptable. So the compiler was originally written to support things like the editor, which has a different set of use cases than take one pass through my JavaScript and generate the smallest possible JavaScript ever because I have different, I know different things at different times. So yes, fair enough, we got dinged for that. But Bob put together this an answer to what we can do now. So here's an example. Let me do. Here's a very simple Dart program. It's not so simple that we did add a class and a static method, and you can call test main. Okay, so there's our Dart code. So if you compile this to JavaScript today, you're going to get this code, which I almost, yeah, I can fit right there. Okay. So this is the code that you're going to get, well, something like this with our new compiler technology. So it's pretty human readable. I like it. This is how most people would create a class in JavaScript, so that makes sense to me. Couple wrappers here, and then function main and call main. So, I would argue a human would write code at least around here, and then this is some of the boilerplate. So we've definitely heard that concern. So if you heard people say, well, you generate 10,000 lines for Hello World, we worked very hard on a new compiler that fixes that problem, and we'll do things like dead code shaking or tree shaking to just spit out just the code that is needed by your program. So, very fast iterations on a project, and we definitely hear your concerns. We know this is clearly a very big one. So with that, I think that's all the demos and talk that I have. So first hand up, good job.
You used the word soon quite a bit in your talk.
Yes.
So do you have anything more specific to say about?
I'm not at liberty to discuss timelines.
Okay.
No, it's the neat thing is it is all open source. So you can kind of track the bugs and watch the discussions and look at the change lists that go through the review process. Sometimes things are held up in discussion of the mailing list. Sometimes things are held up because we haven't gotten to them because we don't perceive that anyone cares about them. So if you care, like go start. And sometimes things get hung up in the code review process. So the neat thing is you can kind of track this stuff in the open, but depending on what you need,
Do you make people participating in projects?
I know we've taken a couple simpler patches. Do you have any count or idea of like?
We've taken a few outside patches.
Couple, right?
Not very many. It's kind of hard because honestly, a lot of the work we're doing right now is like writing a compiler, and it's not something that a lot of people can just like show and be like, here you go. It's kind of cool.
So I haven't seen a lot of discussion on the library. The things like where it hits users. By the way, we're lucky to be joined by two guys from the Dart team. So yeah, very cool. Yes.
Isolates, that's a library feature, or is it a language feature? Because you look like you were.
So yes, right. Kind of both, under my understanding. So yes, so you can extend an isolate, and you have all these nice library. You interact with the isolates via the library. You can actually go to the docs and actually browse all this kind of cool stuff. But of course, the virtual machine will also understand what's going on here and actually create the isolates for you. So the manifestation of the isolates happens in the virtual machine layer, or if you're finding the JavaScript, the web worker layer. But I want to show off Bob's great work here with the API docs. This is actually a user space tool. You can write your own Dart docs. You compile this for your own kind of intranet app. But to your question here, we can actually go into isolate and browse around as you know the library. So it's pretty cool. Question? Yes.
Yeah, I'm assuming that a lot of people who are going to be starting with Dart are going to be sort of injecting it into an existing code base. So I guess kind of two questions on that. What, not can you, because obviously you can, but how do you call some useful JavaScript function? And then two, is there some sort of like an extern style concept where I can sort of give it some type information so I can get some of the benefits of the language side of Dart with my existing code base?
Right. Great question. Something I think the Seattle team here is actively thinking about. It's actually a little bit more complex than might. You want to take it?
I can take it if you want, buddy. You want me to come up? I don't want to
I
don't want to step on your turf.
No. I'll back you up. Make sure we get it.
Hi, I'm Bob. Dart to JavaScript interop is strangely hard, and we don't have a great story for it right now, but we're working on it. The challenge is we want to support having the Dart VM running in the browser too. And when you talk about having a Dart VM and a JavaScript VM both running in their own heap with their own garbage collectors and threads, all of a sudden communication between them gets a lot harder than just calling from JavaScript to a language that happened to be compiled with JavaScript. So we're trying to come up with a story that works in both of those use cases. It's not easy to do.
Did you mention how we can be done via isolates?
That's the current plan. So the current plan is basically the isolate communication mechanism, which is already async, would be the same way it becomes JavaScript.
So we want to be able to execute, I think Dan might say, like 10 calls per second or something. So like if you need to do thousands of calls per second between Dart and JavaScript, probably this thingies, I mean, I don't know if you can optimize with that, but use cases we're thinking of are like the Maps API. Like that's a pretty awesome API, and everyone uses it. Whatever we do, that use case then needs to be square. There's another slight angle on your question, though, which is also interesting on the C side. I've seen people start to figure out how can they inject other libraries like OpenSSL or whatever into like Dart virtual machine or libMySQL. So we also need an answer for the like native side of Dart, so we can inject other existing code there too. Yeah.
What's your story for server-side development? Like, how will it coexist with Node or interops with Node?
Right. So I don't think you would see in a direct literal port of Node.js to Dart necessarily, but I do think that somebody will port something like Node. That is, I want to take what I know about programming in my language on the client and take what's strong about that and bring it to the server side. That's definitely actively being worked on. There was a patch just on like Thursday or Friday or something that moved out a bunch of libraries like I/O libraries and directory browsing, all the stuff that's relevant to the server, into their distinct libraries. That will thus make it much easier to program server-side stuff. Things like network API too. So we have like proof of concept websites.
Does that exist, like network APIs and file system APIs?
Yeah.
So when we talk about the standalone Dart VM, we're talking about this command line application that runs the Dart VM, has some libraries for talking to I/O and network, and that's in Node, but for Dart. So it's getting there. It's just compared to Node, you're not sure yet.
But I guess the greater point is
like, how are you guys going to like leverage existing module landscape? That's again,
kind
I
of
guess,
the
JavaScript,
gentleman's point behind you, right? It's like we have like such a corpus of great JavaScript code out there. How do we inject that into some like sane way so we can take advantage of that? We think it'll be done via isolates, like you can communicate via like a V8 instance and a Dart instance through this isolate mask. That's what would be.
A little more insight into the Dart VM. If I want to see run it on Safari or Firefox, is it a plugin or is it something from JavaScript?
It's not a plugin right now. It's actually, if you go check out the source code for the Dart project, you see lots of directories in there. One of them is VM, and that's all the C code that compiles actually down to an executable called Dart, for instance. As Bob was saying, like it's just an executable you can just run. But then because the C code, just like V8, it's just C code for the JavaScript virtual machine. You can embed that in different things, like people embed virtual machines in their games and whatnot.